Hi guys, welcome back to our Python programming series. In the last video, we were discussing about Python comments and operations. In this video, we will again covering those two topics, continuing them and discussing them in detail with the examples. Let's move to our topic. So yesterday we discussed about the Python comments, in which we saw that there are two types of comments, as in every programming language. In Python, a single line comment starts with a single hash, and a multi-line comment is enclosed within either a pair of double quotations or single quotations. But one more thing I want to discuss here with you guys is that in Python we can also have our string variable in multiple lines. As you can see here, I declared a string variable with the name string, and then I have stored some lines content here in this string variable, which is a multi-line content. So for storing this multi-line content in a string variable, I have also used I have enclosed the content within a pair of three single quotations, or I can also use double quotations here, as I discussed with you that are used for a multi-line comment. So these two things may confuse you, as in Python, if I just remove this from here and I just run this cell. Now, now this chunk of code, at the end of this chunk of code, I have this multi-line comment, and I told you in Python, add anything at the end of our program or chunk of code is automatically printed as an output. So here our Python is confusing this comment with a string and printing it here as an output. So in Python, you will see that if we use a multi-line comment at the end of a chunk of code, our interpreter will take it as a string and print its contents. Now here I'm just putting my code back, and this I initialized a string variable, and then here I'm showing if I print this string variable using a print function, what happens, and if I just write the name of this variable at the end of our chunk of code, then it will again print the contents of this variable, as you can see here. So this was the result of the print statement, and here you can see this again, it is printing and displaying output because of this variable at the end of this chunk of code. But there is a difference in these two outputs. As you can see here, when I'm using print function to print my string variable, it is printing its contents along with the separate lines as I stored in the variable. But while printing the contents, just because the name is mentioned at the end, it is showing that there was a line after. Uh, uh, it is showing the cursor movement of to the next line at every point where I moved to the next line using the escape sequence, which is \n, and it is not actually printing the next line. Then we discussed our Python operators in the last video, and today you can see more about them. We discussed we have 7 types of operators in Python: arithmetic, logical, bitwise, assignment, comparison, identity, and membership operators. Arithmetic operators are very simple, as we can see, and we use in every programming language. We study them and do various exercises on these operations and use them to build our calculator app. So we will also see that example and exercise soon, inshallah. We also discussed this example in the last video with the dry run here, as I have discussed in the last video. You can go and watch it. More about bitwise operators we will discuss today. The bitwise operators actually help us to perform operation on the binary values of our variables. These include AND, OR, XOR, NOT, left shift, and right shift. Left shift and right shift actually shift the binary values of our variable according to their as the name suggests. So here you can see examples of bitwise operators. Here we are doing bitwise AND operator on two variables n and o whose values are 10 and 5, and here I've illustrated the actual calculation being performed inside this instruction. The binary value of 10 is 1010, and that of 5 is 0101. When these are two AND, the result is 0. So 0 is stored in this variable. Similarly, here is an illustration of OR operator between these values. Here is an illustration of XOR between these values. And here is an illustration of NOT operation on n variable, which results in a negative value 11. But to convert this negative value into the actual not value, we perform an AND operation upon with the value we need to get. This is a basic mask for getting our appropriate value and for calculating the not operation uh, on a variable in Python. This thing is a bit complex, which we should leave for now as a beginner, and we can discuss later in our more advanced videos. Similarly, here we are doing not operation on variable O, and here now you can see the left shift. We are doing left shift on the n variable, and value of n was 10 for shifting it to the left for 2 bits. This 2 defines how many bits we have to shift. So shifting the binary value of 10 to 2 bits, here you can see we have added 2 zeros on the right for shifting the value of 10 to the left. So the result will be 40. Similarly, in right shift, we will be shifting the value of the binary value of 10 2 bits to the right. So it was initially 1010, and after shifting it to the right, we have left with only 10. These 10s are discarded, and we are left with 10, which is the binary number of our 2. So we get a 2 as a result in this variable. So after running this chunk of code, we have got these values as a result. After that, we discussed in the last video our logical operators, which are logical and, or, and not. These are just used to check our conditions by returning true or false, or functioning between true or false by checking if the comparison is true or false. These are mostly used in combination with comparison operators, like as shown in these examples. We have taken 3 variables and given them some values, and then compared their values to return either is this comparison true or false, and the result is stored in these variables. Then we are here printing these variables with appropriate messages. Moving to the comparison operators, we discussed in last video, double equals to helps us to check if the two values are equal or not. This not equal to helps us to check if this value is not equal to this value. And greater than or smaller than helps us to check if this value is greater than this, or if this value is smaller than this. And again, these are also used with pair with equal to sign to check if this value is greater than or equal to the value of y, if either x is smaller than or equal to y. These comparison operators also help us return us value in the form of true or false Boolean values, which will be stored to these variables. Here you can see a comparison between x and y values, whose values are 10 and 5. 10 equal to 5 will return false because 10 is not equal to 5. 10 not equal to 5 will return as true. 10 greater than 5 will return as true. 10 less than 5 will return as false. 10 greater than equal to 5 will return as true. And 10 less than equal to 5 will return as false. So these values will be stored in the respected variables. Then we have Python assignment operators. Assignment operators, we have already used them in previous examples as we were storing some, we were assigning the values to variables, or we were storing some results of some operations to some variables. We were using here the assignment operator, which is basically equal to, and always involves an equal to with a pair up with any other operation, which can be arithmetic operations, or those can be bitwise operations. So these operations mean if we use a pair of plus with equal to x plus equals to 3, this means a new value will be stored in the x variable after calculating the previous value of x with some operation. The result will be stored the new value as a new value in this variable. Similarly, in all these operations, we are doing the same. So here are some examples. You can more clearly see all these examples as I'll be providing you my this notebook in the description below, and you can easily go to the link and download this notebook and practice and start practicing your own exercises and problem statements by taking help from these. Then we have Python identity operators, which are is and is not, which help us to check if a variable belongs to if two variables are the same object, are indicating the same object, are the two names of the same object or not. And is not is used to check if both variables are not indicating the same cell in the memory. So here I have different examples for these. Either we have integer variables, as the small integer value 10 is stored in A and 10 is stored in B. So for Python, if I check A is B, it will return me true, because a and b refer to the same object in memory, because these are small integer values. Same integer value, which is a small value, assigned to two different variables. We just can say that Python refers both of those variables to the same cell in the memory, and that is why it is returning me true that a is b. And if I check a is not c, as in this case, a is literally not c, a value of a is 10 and value of c is 20, so it will return me true because a and c refer to different objects. Here, if I take an x variable and make it a list of some integer values, and then I take another variable and just assign it the content of x variable, so it means y is indicating to the x variable, and that means y is indicating the same cell where x is indicating. So x and y are the two names of the same list in the memory. So if I check either x is y, then it will return me true because x and y refer to the same list object in the memory. And also if I check if x equals to y, it will return me true because contents are also the same. It is definitely contents will be the same because the object is the same. Then if I append something to the list y using the name y, that that new value will also be appended to uh, the list which is x is indicating. Why? Because both of these are the names of the same list. So either I can use y for that list or I can use x for that list. Both will update the same list. So here, after appending a value in using y, if I print x, x will also show me a list where 4 will be appended to the previous list. So if I check x is y, it will return me true. And if I have taken two separate variables and I have stored the same lists but separately in two variables, now it will not return me true that x is y, because uh, here the contents are same, but as lists are mutable objects, and these can be changed. I can change y afterwards, but x's value will not be changed by using y because x is not equals to y or y is not equals to x I have declared. So Python will not recognize that x is y or y is x because these have become now two different objects in the memory cell, and two separate memory locations have been assigned to these lists. But if I check if x is equal to y, it will return me true because contents are the same right now. Similarly, if I take two variables of string type and take a very small string in both of these variables, as for now, for a very small string, Python will indicate it as the same object. It will allocate a memory cell to this variable, hello, and when I created this variable once, and then again I created s2 variable with the same content, it will automatically it will not create a separate allocation for this variable, but as it will find the same type of value already present in the memory, it will for that time um, um, just indicate s2 with that cell, with that cell memory and that value already present in the memory. So if I check that s1 is s2, it will output me true, which is the result of string interning. Python often reuses Python often reuses string objects for identical literals. But as soon as I will create a large string, somewhat large string, for about 5 and 5, 11, 11 bits. So a much, a little bit larger string will not uh, allow another variable to reuse it. And so S3 and S4 will be separate variables in the memory and will be separately storing their contents and will not refer to each other, as the output of S3 is S4 might vary. It may change. Python may recognize them as the same object or may consider them as different objects. Depends how what is the limitation of the length for Python for reusing a string. So it depends on implementation, but it's less likely to be true for larger strings. But if I check S3 is equals to S4, then it will output true because contents are same. When I use none data type we discussed will be used in our Python. If I declare initialize z variable with value none, and then I check if z is none, it will output true, and if I check if z is not none, it will output false. Similarly, now talking about tuples which are immutable, which cannot be changed. If I take two tuples t1 and t2 and assign them same values, And then check if T1 is T2. The output might change, might vary. It might be true or false, like strings. If it is a small tuple, maybe it reuse it, or it may not reuse it. It depends. But if I check T1 is equals to T2, it will return me true. Now let's just run this code. Here you can see A and B were two separate variables, but A is B becomes true, and A is not C becomes true. Here X and Y were the two names of the same list. So X is Y becomes true and X equals to Y becomes true. When I printed 4 in Y and printed X, the change was also shown in X because it was the same list. And when I checked if X is Y, it returned true. Then when I took two variables and X and Y and assigned them the same list separately, and then it will not consider it as the same object. And it will return false if I check X is Y. But if I check X equals to Y, it will return true because contents are same. Then I created a list, two lists, and checked if S1 is equals to S2. Although these were separately initialized, but content was same. But the list was the string was very short, so it was able to be reused. So Python reused the same literals. But as soon as I jumped to two words in a string, it didn't took them as the same object and it returned me false. And when I checked if the contents are equal, then it returned true because both have the same literals, exactly the same. Um, then here we checked if z is none, it returned true. If z is not none, it returned false. And then we discussed the tuples. Moving to the membership operators, which are in and not in, which return true if a sequence with a specified value is present in the object. Actually, in and not in are used to check in an iterable to track a value, if it is present or not present in that iterable. That can be a string, a list, a tuple, a set, or a dictionary. And we can also check if that specific object is not in that specific iterable. These two keywords are very essential for that. So firstly, we created a string named hello world and performed some operations. What if we look into the output here? So for checking membership in strings, I created a string named myString and stored hello world in it. Then for checking if capital H in myString, it was present here, so it returned true. For checking small h in myString, it returned false because there was no small h here, and it is case sensitive. For checking if world in myString, so it returned true because all the way it was uh, following the same literals. Then for checking if Python not in myString, then it returned true because Python is not in this string. For checking membership in lists, we created a list, my list, and the contents were 1, 2, 3, 4, and 5. To check 3 in my list, it returned true, 6 in my list, it returned false, and 10 not in my list, it returned true. For checking membership in tuples, created a tuple 10, 20, 30, 40. 20 in my tuple returned true, 15 in my tuple returned false as it was not present there, and 20 not in my tuple returned false because 20 was present. Checking for membership in sets, we created my set, which was 100, 200, 300. 200 in my set returned true as was present, 100 not in my set returned false as it was also present, so we cannot say it is not in that set. Checking for membership in dictionaries, keys only, we can check using keys. So we created a dictionary named mydict, A and assigned it value 1, B assigned it value 2, and C assigned it value 3. A in mydict returned true, 1 in mydict returned false because 1 is not a key. We can only track keys using in and not in. D not in my dict returned true because there was no key named dict D. 2 not in my dict returned true because also 2 is not a key, any key here in this dictionary. Now moving to some complex examples. My list of lists. Here we have a nested list of lists. The first uh, value of this outer list is a small list which is 1, 2. The second value is 3, 4, and third value is 5, 6. So we are checking if 3, 4 in my list of lists, it will return true as it was present here. If 3, 5 in my list will return false because uh, we have here some pairs and there's no pair as 3, 5. My list with strings. Here we have strings as the uh, different values of a string of a list. So checking if ABC in my list with strings, So ABC is present here. So it is in my list with strings. So it will return true. So that's it, guys. This was our Python functions, Python operators, and in the next video we will inshallah will be discussing about decision statements and loop statements. So stay tuned until then for the next videos.